Hi Pre-Calc, this is Mrs. Dickerson. I'm sorry I cannot be there again today, but I hope this video helps you out a little bit to better understand what's going on with these nonlinear inequalities, specifically the rational variety that have a numerator and a denominator going on there. This video is going to serve two purposes. One, to show you this example that you saw yesterday, to explain it a little bit, and also hopefully you can see it a little bit better. I know the scan and the picture that I uploaded were not the best quality, so hopefully this will let you see it a little bit better. Also, in this video, please make note, hopefully this made sense, there are two answers going on here. In the end, it's the same final answer, but how you got there is very different. And the reason this is, if we remember the other day, Sam brought up in class a way for us to solve these problems that was different than how I was going to show you. And I was experimenting with that just to make sure that it worked, and it seems to be working wonderfully. So I just wanted to show you method one, which I'm going to call Mrs. D's method, and this way I'm going to call Sam's method. Both work. You've got to make sure you're doing everything algebraically, legally, and you will be good to go. So let's go through this one. This is the example problem. Here we go. This is from the homework set, but I liked it the way it was set up, so I gave it to you as an example. So here we go. Method one. We're dealing with this problem here, and we see that it's already factored for us. Now for my method, we're actually going to need to FOIL the top, but the bottom can remain factored. So here's my way. What we would need to do is set it equal to 0. That was always the key point of my method, was that we need to get the 0 here. That's super important. So to do that, we just subtract 4 over. But in subtracting 4, it does not have the common denominator of x plus 3, x minus 1. So we need to force that to happen. So this little step right here is where we are forcing the common denominator. Once that's there, I can subtract in the top. I keep my denominator the same, x minus 1 and x plus 3. But to combine the things on top, I would love for it to look more like this on top, where it's easy pieces multiplied together, linear pieces specifically. There's no x squared within this piece. There's no x squared within this piece. Linear would be great. So I FOILed up here, and I got everything, let's see, all of that. And then this guy over here, the negative 4 is still out front, and I FOILed in here. Then I combined some like terms, and I distributed my negative 4, and I get this numerator instead. Notice the whole time the denominator has not been FOILed. I like that it's factored like that. The fact that it's factored like that is going to be helpful for me when I go to get my final answer. The 0 has stayed the whole time. The inequality sign has stayed the whole time. Then, open this up a little bit. Then, once I distributed the 4, I combined a couple like terms. I see I can combine a few more like terms. The 4x squareds cancel, which is super nice for me because, again, notice this is a linear piece up here. There is no x squared. It's not quadratic. So that's going to be nice for when I have to set it equal to 0, see where it's positive or negative. So I have my numerator, this single piece, my denominator, these two pieces, and I want to know how they are interacting to be less than or equal to 0, or another way to say that is negative. So down here you will see 4 number lines. First I have my numerator. I have to figure out when is it positive or negative or 0. Then I have the first piece of the denominator, the second piece of the denominator, and the overall answer. A key to knowing if the whole thing is positive or negative. If